Ocean heat uptake is the fundamental measure of the state of the Earth's climate. Global warming is essentially ocean warming. 93% of the heat of global warming is going into the oceans. Warming heat accumulates in the tropics and dissipates at the poles. Since hot water is buoyant and cold water is dense, the heat of warming is making the ocean increasingly stratified. Sea surface temperatures can reach as high as 35 degrees Celsius, but at a depth of 1,000 meters the temperature is universally about 4 degrees Celsius. The 2023 sea surface temperatures to date have been the highest ever recorded. The 2022 ocean heat content hit a record high of 10.9 zettajoules, roughly equivalent to 100 times the total electricity generated worldwide in 2021. Another way of looking at this, it is 17 times the annual global primary energy consumption. Or in the alternative, it is the equivalent of 5 Hiroshima bombs being detonated in the ocean every second. Over the last 15 years, this accumulation has risen about 50%, compared to the accumulation over the last 50 years. This heat is leading to sea level rise. The alteration of ocean circulation patterns. The alteration of weather patterns, as well as numerous negative impacts on marine ecosystems. As the oceans warm, they expand and encroach on existing land masses. The Arctic sea ice is shrinking at a rate of 12.6% per decade, compared to its average extent during the period from 1981 to 2010. As the Arctic and Greenland ice caps melt, they release fresh water into the ocean, producing added freshwater that is less dense than seawater. This fresh water has caused the slowing of currents in the North Atlantic. The Gulf Stream section of the ocean conveyor system influences the climate of the east coast of North America and Canada, keeping them warmer in the winter and cooler in the summer in comparison to the southeastern states. This conveyor extends toward Europe, where it warms Western European countries as well. The Antarctica's ice sheet is weakening due to contact with warm ocean water, carving channels into the underside of the ice shelves all around Antarctica. Ocean heat is producing thermal expansion of the oceans and seas. Water evaporates, and for every degree Celsius that Earth's atmospheric temperature rises, the amount of water vapor in the atmosphere can increase by about 7%. The combination of ocean surface heat and increasing humidity is a driver of tropical cyclones and marine heat waves like the blob that began in 2013 and persisting until 2016. At its greatest extent, this warm patch encompassed millions of square miles of ocean, from Alaska and British Columbia south to California, where sea surface temperatures reached 3 degrees Celsius above the long-term average. Marine birds, whales and sea lions starved and died by the thousands. As tropical oceans warm, they release dissolved gases like carbon dioxide and ocean. The carbon dioxide increases the greenhouse effect. The loss of oxygen in the ocean produces dead zones and leads to smaller fish and smaller fish catches. Levitas estimated between 1955 and 2010 the oceans warmed between the depths of 0 to 2,000 meters by 0.09 degrees Celsius and noted that if all of that heat was transferred to the lower 10 kilometers of the atmosphere it would be warmed 36 degrees Celsius.